So our today's topic is formation of differential equation. Some practical example or some scenario will be given, and we have to make the differential equation by ourselves. Suppose we have this one. Before starting this one, I would like to explain two, three things. The first one is whenever we have to start a given differential equation, so you have to remember these things. So formation of differential equation. Our today's topic is formation of differential equation. Sometimes differential equation will be given and you have to solve, and sometimes the differential equation you have to make, and after making the differential equation you have to solve. You have to consider three, four things. The first one is, I will start with the blue marker. The first one is whenever we have the word rate of change, this means you have to write the d by dt. If you have the second one is number 2, rate of increasing. Whenever we have the rate of increasing, then you have to write plus d by dt. Whenever we have the word rate, this means derivative with respect to time. So whenever we have the word rate of decrease, this means you have to use minus d by dt. Derivative with respect to time. The fourth one is, that is very, very important. If you have, suppose the birth rate of increase of population. So a rate of increase of population. Increase of population. So in this case, you must have a birth rate minus death rate. And sometimes we have the formation of a substance in a chemical reaction. Formation of substance in a chemical reaction. So in this case, another example over here, we have just like we have this container, and sometimes we have water in this container, and some water is inflowing over here, and some water is flowing out of this container. Suppose that this is the container, or this is the reservoir, or this is any vessel, or this is any information. We have this one. Some liquid is coming over here, that is called a flow in. And due to the leakage of the water, suppose that is dropping out of this container, that is called flow out. Suppose the flow in, suppose the water is coming with the 5 liter per, suppose that minute. And flow out, the water is flowing out at a rate of, suppose 2 liter per minute. So per minute, how much water will be stay in this container? So that will be 5 is coming, 2 is leaking out. So 3 liter per minute will be over here. So rate of increase of volume, that is called dV by dt, is equal to the flow in and minus flow out. So these 4, 5 scenarios you have to discuss. And if other scenarios will come, I will explain according to the statement of the question. So the first one is whenever you have the rate of change, you have to use the positive derivative with respect to time. If the rate of increase positive, rate of decrease negative, rate of increase of the population, then you must have the birth rate minus death rate, and some reservoir is here, or some flux is over here, and some water is coming inside this container, and some quantity of the water is coming out of the container. So how much water is left over here? So you have to write this one. Derivative rate of increase of volume, a rate of increase of volume, that will be the flow in minus flow out. One by one, I will. We have the 4, 5 scenarios, 4, 5 situations, and you have to write this 4, 5 scenarios situations and translate this one into mathematics. I will erase this one. So erasing all my drawing. The first one is write the following differential equation. So first I have to explain this one. What's the statement of the question is over here. Write the following as differential equations. Do not solve the differential equation. Just you have to make how you will make the differential equations. I will use the suppose green marker. The rate of decrease of the height of the water in the tank. Before starting the question, what's the meaning of this one? I am using the word height. So whenever we have the word height, you have to use H, and whenever you have the word time, you have to use T. So what's the relation is over here? The rate of decrease of the height means rate of decrease of H. So what information we are getting? Rate of decrease of height means rate of decrease of H. And as I said, whenever you have the word rate, this means you have to write d by dt of. That stands for the rate of decrease minus sign of height. Height is denoted by small letter h according to the question. In a tank is proportional. This sign stands for the proportional to the square of height. Square of height means h square. So that is the relation. You have to make this one. And we know that when we have to remove the sign of proportionality in the physics, chemistry, as well as mathematics, you have to put one constant of proportionality over here. So you have this one, dh by dt. Sign of proportionality will remove with the sign of equality, k times h square, where k is the constant of proportionality. You have to mention this one. Now, usually the left-hand side of the derivative must be positive. So I will write this one as dh by dt is equal to the minus k times h square. So that's the required equation for the first scenario. That is the required differential equation for the first scenario. The first part, A part, is over here. Now we have the second part. I will choose the blue marker. The second part is B. For the number of infected cell is N. Number of infected cell is N. So whenever you have the number of infected cell, we have to use N. And whenever you have the time, you have to use T. So what's the meaning of this one? The rate of increase of number of infected cell. I will change the rate of increase of N. So rate of increase of N means d by dt plus sign of N. N is shows the number of infected cell in a body is proportional to, not equal to. We have to write proportional to. Proportional to the number of the infected cells. Number of infected cells means N in the body at that time. Now again we have to remove this sign of proportionality. So I have this one dn by dt is equal to the k times n. So you have to mention what is k. K is sign of constant of proportionality or the sign of proportionality. So I have this one, the constant of proportionality. Now the next one is the question number 3. The third C part of the question is C part of the question is just like this one. Suppose the green color I will use for the C part of the question. So C part of the question means says that C part of the question is this one. Whenever you have the word velocity, I will replace by V, small v. And whenever you have the word t, you have to replace by small t, time. So the first sentence of question C part, the rate of decrease of the velocity. So minus sign, rate of decrease, d by dt of velocity moving in a fluid is proportional to the product of the v and v plus 1. So you have this one minus dv by dt. Again, the sign of proportionality is changing the sign of equality by k times v into v plus 1. You have to write again what is the k? K is called constant of proportionality. And as I said, the minus sign you have to write always right of the given differential equation. So you have to write dv by dt is equal to the minus k times v plus 1. That is a differential equation. Now I have the E part. Sorry, D part. D part will be just like this one. And now I will solve the direct method. The rate at which the oil is decreasing. Oil is not decreasing, the word is leaking. So leak means decrease. So whenever we have leak means decrease. Now I will try to make it directly because I have the practice of the 3 questions. So I will start this by direct method. Rate of decrease of oil is leaking. Oil is leaking means the volume of the oil is decreasing. So you have to write dV by dt. Decrease means minus sign. From Indian is proportional to. So this sign proportional to the volume of the oil. So that is equal to the V. dV by dt. That must be equal to the minus K times V. Now E part of the question is by using the other color over here. Suppose the color is black. E part of the question is the rate at which the cost of an item before starting the statement, just express the representation. Whenever we have the word cost, this means C. And whenever we have the word time, this means T. So the rate at which the cost d C by dt, rate of decrease of increase of the cost is plus sign proportional to the cube of the cost C cube, and dC by dt is equal to the k times C cube. C shows the cost and k shows the sign of proportional. Sorry, we have the constant of proportionality. And the last one is over here. The E part, not the E, that is the F. So F part of the question is, I will use the red marker. So this is not red. For the speed v and the time t, the rate of change of the speed, rate of change means always dv by dt. of a skydiver just after the jumps off plane is inversely proportional to 1 over e raised to power t by 2, and it will becomes dv by dt is equal to the k times k over e raised to t by 2. So that's the way to make the differential equation. Now, after making the differential equation, how you will make and solve that given differential equation? For this one, I have to use the next topic. I will erase all my drawing. Moving to the next page. Question number 13. A large tank is full of water. The tank starts to leak. So I have to make the diagram first, and then it will be easier for me to explain the question. The tank is just like this one. I will make over here. So this is the tank pose. And that tank is full of water. So that tank is full of water. The first one is a large tank is full of water. The tank starts to leak. T second after the tank starts to leak, the depth of the water in the tank is X meter after T second. So I have to move this one. So that's the scenario. So this height is given. That is the X meter. At T starts the tank leak to T seconds after the tank starts to leak. The depth of the water in the tank is X meter. Depth means always from bottom to this one. So that depth is given with blue marker. So that depth is given X meter. And that X meter means whenever we have the time T seconds, depth is denoted by X meter. The rate of decrease of depth, and depth is denoted by X. And whenever we have the word rate, this means derivative with respect to the time is proportional to the square root of the depth of the water. So proportional to the square root of the depth is always X in this question. So you will get the differential equation. Write down a differential equation relating xt and constant of proportionality. So I have the first part of the A part of this question is dx by dt is equal to the leaking. Whenever you have the word leak, that means minus sign, minus k times under root x. Minus k times under root x. The rate of decrease of the depth of the water is proportional to the square root of the depth of water. Square root of the depth means under root x. Write down the differential equation relating xt and the constant proportionality. So we have the x is over here, time is over here, k is over here, and again the x is over here. So that's the answer of the first part A. So this is the answer of the first part A. The second part of the question I will solve with the other color. Suppose the color is green. I have to solve the B part. At the instant when the water starts to leak from the tank, the depth of the water is 6.25. Starts to leak. Whenever we have the word starts to leak or whenever we have the word initially, then means time is equal to zero. Why time is equal to zero? Because at that time you starts your observation, you starts your stopwatch. And stopwatch when you start, this means the time is zero. For this experiment, for this observation, and you know that the time never becomes zero. So when you start your observation or you start your experiment, time is equal to zero. At that time, The depth of the water means x is equal to 6.25 meter. Given that 120-second later, another information, 120-second later, what's the meaning of this one is when time is equal to the 120-second later, the depth of the water is 4 meter. At that time, x will be 4 meter. Solve the differential equation expressing t in terms of x. Now we have to solve the differential equation. Okay. So the differential equation is given. I will try to solve this one by this brown color. So I have this one is dx by dt minus k times under root x. As we know that day before yesterday, when we started the differential equation, as I said, the left hand side must be on the terms involving the derivative, and the first you have to remove this denominator. So you have this one dx is equal to the k times under root x into dt, minus sign will remain over here. Now you have to separate the variables. What's the meaning of separate the variables? There are two variables. The first is whose derivative is taking, that means x. The second is with which the derivative is taking, that is t. So the terms of x you have to write on the left hand side, and the terms of t you have to write on the right hand side. So I will get 1 by under root x times dx on left hand side and minus k times dt on right hand side. After separating the variables, then I have to take the integral on both sides. And as we know that no term of the x in denominator, so you have to find the integral x raised to power minus 1 by 2 dx and minus k, because that's the constant. Only two variables are over here. The first is x, the second is t. Integrating both sides, minus 1 by 2 plus 1 divided by 1 by 2 is equal to the minus k as it is. The integral of the 1 is just t and plus c over here. Now two set of informations are given to find the unknown constants. What are two informations? The first one is this red color. When time is equal to 0, x is equal to 6.25. So I will use this one. That will becomes 2 times under root x is equal to the minus k times t plus c. So put the first set of information that you have to put over here, the whole set of information. What will you get? After substituting the value, I will use the blue marker. 2 will remain as it is under root. 6 means we have this one is 6.25 is equal to the, that becomes 0 plus c. So the value of c becomes 6.25 is the abbreviation, is the, sorry, the square root. Square root of 6.25 becomes 2.5 and 2.5 multiplied by 2 becomes 5. So the value of c is 5. Now you have to find the value of other constant. What will be the value of other constant over here? You have to put the second value. So again, t is equal to 120, x is equal to 4. So 2 times that value you have to put with the this color. So that expression you have to put over here. So this 2 as it is, under root sign as it is, and you have to put x means 4 is equal to the t means 120 minus as it is, k as it is, and the value of c is just plus 5. So you will get 2 times 4 minus 1. So minus 1 becomes minus 120k. Marker is just light color. I have to use a little bit dark. Minus is cancelled with minus. The value of k will be 1 over 120. Hence, the differential equation becomes, what will be the differential equation? Differential equation becomes 2 times under root x is equal to the minus. What's the answer of k is 1 over 120. T as it is. What's the answer of c is plus c5. So that's the answer of this expression. But the last step is that question is express t in terms of x. So you have to make t as the subject of the equation. Changing the color of my marker with the black. 1 over 120 t you have to write on the left hand side. All terms minus 2 under root x. T will becomes 120 into 5 minus 2 under root x. That will be the answer of this expression. And that will be the solution of this one, expressing t in terms of x. Find the time it takes for the C part of the question. Find the time it takes for the depth of the water to half. So C part of the question is over here. That's for the C part of the question. Using the red marker. So that is the C part. C part says that you have to find the time. This means time is unknown. For the depth of the water to half, the total depth of the water is 6.25. So depth of the half means 6.25 over 2. That's called the depth of the water is half. So you have to use your calculator. So you have to find the time. 120 will as it is, 5 will as it is, minus will as it is, 2 will as it is, under root. You have to write over here 120 over, sorry, not 120. That becomes 6.25 over 2. 6.25 over 2. If I'm not wrong, you have to use your calculator and get answer what the answer is. 6.25, it becomes 2.5. So 125 as it is minus 2 into 2.5 divided by under root 2. Now, I don't have the calculator right now, but you have to use your calculator to find the answer of this time. The next part of the question is, after clay, not next part, the next question is question number 14. A liquid is heated so that is its temperature is x degrees Celsius after t seconds. So after t seconds, when time is equal to the t second, its temperature will be x degrees Celsius. It is given that the rate of increase of x means dx by dt, is proportional to the 100 minus x. The initial temperature of the liquid is 25 degrees. So whenever I have the word initial means temperature at time 0 is x is given, that is 25 degrees Celsius. So what will you do over here? Make the differential equation, form a differential equation relating x, t and the constant of proportionality. So this one, the A part of the question is, A part I will solve with the blue marker. So that will is equal to the A part, that information is given. So dx by dt is equal to the k times 100 minus x. Only three unknowns, x, t and t. That's why the B part of the question is solve the differential equation and obtain expression x in terms of t and k. So again, whenever we have to solve the differential equation, first of all, the terms of the derivative must be on one side. Already that terms is on the one side. 100 minus x times dt. Now what will you do? You have to change the terms of x on one side. So 1 over 100 minus x dx over here and k times dt over here. The constant other than the x and t, it's your choice. You can put either on the left hand side as well as on the right hand side, and result will be the same. So after separating the terms, you have to integrate. So integrating left hand side, integrating right hand side. Now we have the denominator involving the terms of x. That's a rational function. What was the formula of the rational function? Very first formula. What was the formula? Integral of, we have f of x over here, f of x over here dx. If denominator involves the terms of x, its whole power is 1, and the derivative of the denominator is the numerator, f dash of x, then it becomes log natural of absolute value of f of x plus c. So what will be the answer of left hand side? The denominator is the terms of the denominator involving the terms of x. The whole power of the denominator is 1, but its derivative is not over here. So you have to multiply by 1 over here and divide minus 1 over here. So minus log natural of 100 minus x is equal to the, that is a constant. That constant will multiply by this variable. So that becomes k times t, and plus c is the constant of integration. Now we have to find the value of c as well as the value of k. The first set of information is when t is equal to 0, x is equal to 25. So I will write minus log natural of 100 minus 25 is equal to the k times 0 plus c. So the answer of c becomes minus log natural of 75 if I'm not wrong. That value of c you have to substitute over here to get the expression. So that value of c you have to substitute over here. What will you get the answer? Answer will be minus log natural of 100 minus x. Then you have this one, the c is equal to the k times t minus log natural of 75. Now, after putting these values, the next part of the question is just you have to make the differential equation. So that's a differential equation. It's okay. No requirement that which letter, which variable will be the subject or which not. So hence the solution will be of this equation will be shift the terms of x on one side. So log natural of 75 minus log natural of 100 minus x is equal to the k times t. That is the differential equation. C part of the question is, what's the C part? After 180 seconds, the temperature of the liquid is 85 degrees Celsius. I can make it simplify over here. Just I erase the things. After erasing the things, I will get over here by using the laws of logarithms. Log natural, that becomes 75 divided by 100 minus x is equal to the k times t. Now the C part of the question is, the time is 180 seconds. Time is 180 seconds, and at that time the liquid is 85 degrees Celsius. X is 85. Find the temperature of the liquid at 195 seconds. Second part is find the temperature of the liquid after 185 seconds. So you have to find the temperature after 195 seconds. So first you have to find the value of the K, and then you have to use the next information. So changing the sign, we have to use this color. So t is equal to 180, x is equal to 85. That becomes log natural 75 divided by 100 minus 85 is equal to k will remain as it is. That becomes 180. So what's the answer of this one is log natural of 75 over 15 is equal to k times 180. Similarly, find the value of k. That becomes 1 over 180. 75 over 15, that becomes log natural of 5. Hence, what will you get with the suppose blue marker with the red green marker? Log natural of 75 over 100 minus x. The value of k is 1 over 180 log natural of 5 times t. Now the second part of the question, you have to find the value of x. You have to find the value of x when the time is 195 seconds. So x is unknown when time is 180 seconds. Sorry, 195 seconds. So time is replaced by 195 seconds in the above equation. So I will get this one is with the black marker. Log natural of 75 over 100 minus x 180 log natural of 5 times 195. Now you have to use your calculator and find what the answer is. That's very simple. If you want to remove the log, so that there must be only one log, only one each side. So I have this one, the 75 over 100 minus x. That becomes 195 over 180. 195 over 180 times log natural is over here, log natural of 5 over here. And that expression, that have become the power of this one. So the log and log will be removed. So I have this one is log natural. Okay, beta, just wait. After the 1-2 minutes, I will rejoin. Thank you, beta.